Hi everyone, this is the part 9 of the course Statistics for Everyone towards Data Science with R. In this part, we are going to study the two level of measurements, namely those which are qualitative and also different types of tables. As we've seen before, there are 5 levels of basic measurement scales, from which of them are qualitative. They are A. Nominal categorical variables which are not ordered, such as gender and religion. One can assign numbers like male equal to 1 and female equal to 2 for genders, which has no real meaning other than differentiating between these two different types of gender. In other words, they are just the names or labels, and we need them to do computations and conduct statistics. We have a package called ggplot2, which has a high quality plotting. In order to use this, we have to first install this, and to do installing, we have to go to Tools, the first choice install packages, and we write the ggplot2 and hit install. And as we see, it started to installing and finally is installed. After installation, you have to read library package ggplot2 was built under R version 4.0.3. We want to plot a data frame with nominal variables apple, orange, bananas, grapes, and pears. df, we have fruits count, apples 4, oranges 10, bananas 29, grapes 14, and pears 20. And we will see the plot, which has bananas the largest one and pears the second largest, and also the legends. Here AES means axis, sets the axis, and fill equal to fruits makes the colors, and also plot the legend automatically. Finally, geom bar makes the bar plot. B, the second qualitative variable is ordinal variables, which can be ordered, but the differences are meaningless, such as ranks in a running race. First, second, third, these 3 ranks are different, but they don't tell how much distance there is between 2 ranks. Rank equal to first, second, and third. You have data frame of rank and places 3 to 1. Data frame, place 3 to 1, Q. Finally, we got the rank first, rank second, rank third. Also, we can use pie chart for nominal data, which gives the percentage of each object. As we see here, the example of fruits, we do this by writing the same and to count, and let's take this as new data frame name. Labels is printf, which gives this percentage, and finally pi dg labels equal to labels. Clockwise true means that uh, draw the circle in the clockwise direction. The circle radius of the circle 0.8 and colors with different colors. We have border of the circle is black and CX is the the is required is the scale. Cx is the scale of the circle and the main percentage of fruits. This is the title of the plot. We move to tables. In particular, in practice, the more frequent cases, we have a data set of variables for each person in a data set. In this case, we can do tabulation with table xtabs or ftable. These functions will generally work for tabulating numerical vectors as well as factor variables, but the latter will have their levels used for row and column names automatically. Here it is a good practice to convert numerically coded graphic categorical data into factors. Categorical data are usually described in forms of tables. This section outlines how one can create tables from the data and calculate relative frequencies. One-way table. In math library, there is a data called painters. So we need also first install the math library, math package. Again, tools, install packages, hit install, and as we see, we installed the package successfully and read the library and was built. Attach, we use the attach. Painters is a data which is a part of math library or math package. So we need to call by the attach function and data painters and head painters. We see the head and we have one composition, drawing, color, expression, and score. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 columns. Steer painters data frame is 54 observation of 5 variables, composition integer, drawing integer, color integer, expression integer, score factors with 8 levels A, B, C, D, E, F, G. We see that the data has 54 observations with 5 variables, from which the score variable is a factor variable with 8 levels. With table function of the score variable, we get the count of each factor level. Then we plot this count as a bar plot. Score, one way, A, B, C, D, H, 10, 6, 6, 10, and sum 54 bar plot. And we see the bar plot of A, B, C, D and their count. And finally, we need to detach painters from the library. Two-way table. Two-way table, we deal mainly with two-way tables. In the first example, we enter a table directly as as is required for tables taken from a book or a journal article. A two-way table needs to be in a matrix format. Example, we take the data frame from this site, github.com. This is my GitHub account, data sets, and this data is read CSV, popular baby names CSV, and we have a string as factors equal to true. If we don't write this string as factors equal to true, what we see is data frame. If we structure, we see that the gender, year of birth integer, gender character, ethnicity character, and this one is child first name character, count integer, and rank integer, and Icelander also Asian and Pacific Islander and so on. But what we need is here above the gender and ethnicity, which are character. In order to change them to factors, we need to add this string as factors equal to true. If we run this again and get the string function, we see that gender and ethnicity change to factors. First gender 2 levels and ethnicity with 7 levels, Asian and Pacific and so on. We read the data by read CSV function in which the second argument string as factors equal to true change the character variables into factors. Using a string function, we see that the gender, ethnicity are factor variables with 2 levels and 7 respectively. Okay, we use the table, data frame gender, table, data frame ethnicity. Table, we see for each 7 level, we have 2 level female, male, and maybe I can do this windows a little bigger to see again. Table. I don't know something what happened here. Okay, this is a table, female, male, Asian, Pacific, Asian and Pacific, Icelander, black, non-Hispanic, black, non-Hispanic, Hispanic, white, non-Hispanic, white, non-Hispanic. Okay, if we want to plot, we bar plot TB, Y label count, main means the title, legend text is female, male, and color equal to blue and light blue. So we see that the female and male legends, also the count of each 7 levels. Next example, we have a data set of restaurant, steer. We have data frame of 244, observation of 7 variables, total bills numeric, tip numeric, sex character, smoker character, day character, time character, and size integer. Again, we can change this character variables to string as factors مساوی true or t, and we see that all the characters turn into factors with 2 levels, smoker 2 levels, date 4 levels, and time 4 levels. Now smoker and day, we see bar plot, and we see the smoker and non-smoker. Friday, Saturday, Sunday, Thursday. Example 3. X tabs total bill, smoker plus day. Data that. X tab happened. Yeah, okay, sorry. This one is with small x. So bar plot, you see, again, in this case, two-way table plot. Exercises do the X tab with type variable. Let's do again this one. Okay, the difference is this. There are some differences. All right. Multi-way table. We have X tab total bill with smoker plus day plus 6. So we have the 6 female, day, smoker, and days, 6 male, day, smoker. Do the same for tip variable. More samples, examples on multi-way table. X tabs, we have here female time dinner, 6, day, smoker day, 6 male time dinner, male, day, smoker. So here we have time is dinner with female, male, here we male time is dinner, we have female time lunch, we have male time lunch. Multi-way tables. One can also get the proportion of the tables with proportions X tab smoker. In the case of a metric, this is the same as prop table as we see in the following. Let's define a matrix. The number of rows is 3. Let's see matrix. So we have a matrix of 3 by 3. The name of matrix, row of matrix, column of matrix. Proportion matrix. 1 means row-wise. Row-wise proportions. And then we can use prop table. Matrix 1 is the same as row-wise prop. Can see A 51, 51, 56, 56, and 24. The same for column-wise. We have seen here, we have the 37, 36, 37, 36 are the same. Bar plot. Okay, A, B, C with the corresponding frequencies, all tables. F tables. F tables creates flat contingency tables. Similar to the usual contingency tables, this contain the counts of each combination of the levels of the variables or factors involved. This information is then arranged as a matrix whose rows and columns corresponds to unique combination of the levels of the row and column variables as specified by row.vars and col.vars respectively. If table is a generic function, its default method ftable.default first create a contingency table in an array form from all arguments except row vars and col vars. Here we have the data Titanic, ftable Titanic, row vars equal to 1, 2, col vars survived. C. We see survived, no or yes, class and sex, male, female, first class, second class, third class, and crew. And we plot this as we see. First plot, first, second, third, and crew, the left-hand side. Here we have the left-hand side. Second plot, first, second, third crew, right-hand side. And we have also the legend clearly showing that male is black, female is like the female is red. F tables on empty cars. Empty cars is a part of our package, and we take this empty cars with the cylinder, VS, AM, and gear. F table, cylinder, VS, and gear, and F table X row vars C 1 2 beside equal to true. Besides means we want to bar plots side by side. Beside means side by side. Okay, we have the side by side, side by side, side by side, and F table, empty cars, cylinder, empty cars VS, empty cars EM, empty cars. We can use this also with this code. Okay, there is also a dataset part of our package, UCB admissions. Data, University of UCB admission. University of California at Berkeley, admission data, and data frame as data frame, UCB with the we check the type of or class of UCBA UCB admission, which is a table. The class is table, and we want to read it as data frame. So we say DF is as data frame UBC admissions. Now STIR, we got again a table number, attribution, dimension names, admit character, gender character, department character. TB, one is X tabs, frequency, gender plus admit, and data frame. Proportion, TBL, gender, proportion, TBL, admit. Here we have admit, gender, male. The male is proportion of admitted rejected is 100. Proportion of female is 100. Here we have gender, proportion of male and female 100. Rejected, proportion of female and male 100. In package AER, we have a data frame. We already installed this package. Oh, there is loading required packages. Survival. Okay. Data. Head. We see that data is about wage, education, experience, age, ethnicity, region, gender, occupation, sector, union, and merit. Data frame is 534 observational, 11 variables, wage numeric, education numeric, experience numeric, age numeric, ethnicity factor 3 levels, region factor 2 levels, gender factor 2 levels, occupation factor 6 levels, sector factor 3 levels, union factor 2 levels, no and yes, merit factor 2 levels, no and yes. This is as exercises for you. Compute one-way, two-way, multi-way, X tabs and F tabs of some of the variables and plot them. Thank you very much for watching and see you next time.